Welcome everybody to this week's Azure and AI Show. And we've got three new speakers with us this week. We've got Rex, we've got Gorkan, and we've got Dr. Tajay. And Rex is going to go first. We also have our 30-year Microsoft MVP with us, Hal. How are you doing, Hal? Congratulations again on reaching the 30-year milestone.
Thank you. I'm doing well. Hopefully everyone else is as well.
Very good. So I'll hand it over to you there, Rex. I have your slides up on the screen, and you're going to do some stuff on Azure functions and network security. Over to you.
All right. Thank you, Frank. Good day, everybody. Not sure of the time zones everybody is in, so I'm just going to keep it with that. And now morning, evening, or afternoon. So Azure functions and network security, can it be done? That's the big question of today. So my name is Rex de Koning. I'm a senior cloud engineer at a company called InSpark. I've been an Azure networking MVP for 2 years now, and hopefully soon we'll get to hear if it's going to be another year. If you want to reach out to me, you can reach me on these socials. If you scan the QR code, you will get all the links on your screen. All right, so what are we going to talk about? What are function apps? Just a short overview. How do we call them? We're going to talk about VNet integration, not gateway, and what happens if public access to a function app is denied, and how we can reach it using a VM, API management, or a front door. But first, what is a function app? Basically, a function app is basically a web application, only it's serverless, so it's not exactly the same. And there are a couple of big differences between the two of them. And one is, for example, in a web application, you can use all kinds of types of authentication, which you don't have in a function app. There you have different authentication levels, being anonymous on function level or on admin level. The demos that I'm going to show you later on are all on the anonymous level, so we don't have to provide any tokens to see the web pages. So basically what happens when you call a function app? If we call the URL, and I know it's a bit small, but we'll see in the demo after this. So what the user does, he types in the address, the function app gets called, and in this case, the function app makes a call to a third party, which will return the IP address of the caller. So if we're going to look what that's, how that is going to look, let me just copy this. And if I go to my screen, so basically what happens, I call my web app. I'm not sure if it's readable, so let's make it a bit bigger. And what the web app does in this case, this is my client IP, so my IP address at home where I am now. And this is an IP address that's related to the function app that we're calling. So if we're going to look at the function app, then we're going to see, if we're looking at the networking tab here, it takes a while to load. Let me see what the address was again. 40, let's copy this. So here we have about 25 addresses that are used by this specific function app to reach out to the outside world. So theoretically, every time somebody would call this function app, they would see another outgoing IP address. That's not always something that you want because of IP whitelisting at third-party sites, for example. So if we're going to look at something else that we can do with function apps, there's something that's called VNet integration. And basically what VNet integration does, is that it integrates your function app or your web app into a virtual network, and it will make a reservation in a subnet that can only be used by your function apps. And by doing it like this, there are some nice things that we can do. So for example, we can use private endpoints, we can use user-defined route tables, we can use security groups, and we can use NOT gateways. So this basically means that if we use a network integration, we can steer how the traffic from our function app goes to the outside world. So if we use a user-defined route table, for example, we can route it towards a firewall and do some checking there if we're allowed to go to that site or whatever. We can use network security groups instead of a firewall to close some ports up or exclude addresses that we are not allowed to reach. Or, and that's an example that we're going to show in a minute, is use a NOT gateway. So basically what the NOT gateway does is it picks all the traffic that comes in and sends it out via the designated IP address of that NOT gateway. So if you want to reach a third-party website, which I'm going to do in this case, to get the IP address, you will see that it will not return one of the 25 IP addresses that is attached to my function app, but it will only return one IP address, and that's the IP address of the NOT gateway. And a lot of third-party sites will prefer that, because now they only have to whitelist one IP address and not all 25 of them. So if we're going to look what that looks like,
Yeah.
So if we're going to go to that website, so I've got a different website for that. Let me scale this up again. So at this moment, you will see we get the IP address 2082.43.153. And if we look on the networking tab here, we will see that is still one of the addresses in this list. And that is because although we have virtual network integration, so our virtual network, our function app is connected to the virtual network demo 1 and the subnet function out, we can see here that there is the NOT gateway is not yet configured. So if we're going to select the NOT gateway, and then, oh, sorry, we're going to tie it up to my subnet, and then I'm going to save it. So we now go back to the web application. Sometimes it takes a while. All right, so we can see now that it's attached. So if I now do a refresh here, we will see that we get another IP address, 20.238.255.2. And if I done it correctly, that shouldn't be an address that's on this page, which it still is at this time. So I probably was too quick. Sometimes it takes a little while. I'm guessing it's cached at the moment. Let's try it on a screen. Giving me back the same address for some reason. Let me quickly check my NOT gateway. Oh, sorry. It did give back the wrong address. For some reason, it inserted it in the list there. But the address that we get back is the IP address now of the NOT gateway. And so now we have a fixed IP address that we can give to our third party and whitelist it. to be honest, I'm not sure why it was now inserted in this list. It didn't do that before, so I guess there's a new feature in the portal that it automatically injects it there. Oh, sorry. But so basically what we just saw is we call our web application basically the same as we did before, but it's now tied to a virtual network, and from there it goes to the internet and it calls the specific website in this case, and it returns the IP address with that one address. And after we connected the NOT gateway, which is a different device that comes in between, we will see that it returns indeed the public IP address of the NOT gateway. But this is only for the outgoing traffic. And of course, you also want to have control of what happens with incoming traffic, because you don't necessarily want your function app to be reachable for the whole world. So that's why what we're going to do in our next demo is we're going to close off the function app completely so that it's not reachable from the internet. The outgoing traffic, in this case, we're going to route through a firewall instead of a NOT gateway, basically just because we can, because the effect is the same for this demo. And then we're also going to see that we can still reach the website on its normal name using a front door, an API management, or via a virtual machine, for example. So what is that going to look like? If we're now going to call our website, I'll just pick this one again. So now we have a website that's closed off for public traffic. So we will see that it's an error 403 forbidden. And if we're going to look at the function app, we can also see that public network access is disabled. You can see here that there are some private endpoints, which we will talk about later on. We will also have virtual network integration again. And in this case, we don't have a NOT gateway, but we do have a route table. And if we look at that route table that's connected to the subnet, it will just route all traffic, so 0/0 sitter, and route everything towards this IP address, which is my firewall. So what is that going to look like? So for example, since we have the function app closed now, what we can do is we can have a virtual machine in the same network or in our Azure environment. We can call this website, and we should get back an IP address. So if I go to the virtual machine now, and we're going to connect here. Oh. And it should be here because copy and paste doesn't work. So I tried this before. So now if I call this website, you will see that from here it works, because we're in the same virtual network in this case. So we don't come in from the internet. And you can also see if I do an NS lookup towards this site, that it has a private link basically in its host name, which means there's a private endpoint connected to this. So we can only reach this web application on its internal IP address. So that's why it doesn't work from the outside world. So that's why we get, for the same website, we get a 403 forbidden here. So we can see the website is still working. It works basically as expected. But this is only from internally. So if we want to show the website externally, which is still an option at this time, there are some other things that we can do. For example, you have Azure Front Door. And for Application Gateway, this will work the same. But for this demo, I decided to use Front Door. So basically what we do here is we have a Front Door URL. Let me copy it already. So when we go to the Front Door URL, the user goes to Front Door goes via a private endpoint towards our function app, and from the function app it goes towards the external site again. So if we're gonna try that one and paste in that URL, you can see that I'm still coming from my own IP address, even though I'm going via Front Door. But now I'm going towards this IP address, the 4074, and that should be let me see, where is it? Demo 2. And that should be my firewall IP address in this case. So the 474.449, 474.449. So even though I now come in from the Front Door, I'm going towards the function app, and from the function app, I'm going to the external site. The traffic is now routed through our firewall, so we can also set up rules in the firewall that we can go to certain sites or we cannot. Instead of Front Door, we can also use application management. And if we go there, so for application management, I just created an API that points towards my function app. And I can just do a test here. The screen is now too big, but here we have the URL that basically gets called. So if we put that in, then we will still see that it will go, that the request is still coming from my local PC and it's going out via the firewall. And you might ask yourself, why is it a better thing than to just go outside directly from the function app? And that's just basically security. So now all incoming traffic goes via the Front Door or via API management, which is a whole different attack plane or a smaller attack plane than going directly towards the web application. If we use Front Door, we can also put a web application, a web application firewall in between, for example, to filter out malicious traffic. But we can still call the website directly from our internal network or from on-premise if we have a direct connection to our Azure environment. And it's just to keep things more secure. And also if we look, for example, in the firewall, so I just got a simple firewall rule here. And in this case, I just have one for the demo. And it just allows all traffic. That's also why we call it do not use in production. And this basically allows all traffic to the outside world to be allowed. So also when we going to look in the log files, for this firewall, firewall log data. So here we can also see all the outgoing traffic. So here we see, for example, this is my VM. So the test I just did from the VM towards the specific third-party site. And this is traffic from the front door and from the API management, because that comes in via the private endpoint. You can also see that it calls different IP addresses in the backend. That's why I opened up all traffic, not to block anything. But this way you can also log all your outgoing traffic and see what it does, and monitor the firewall rules that it's hitting in that case. And with that, we're basically on the end of this lightning talk about Azure Functions and network security. If you want, some of the code is downloadable there. It's also reachable via the QR code that I showed in the beginning. Thank you very much. And if you have questions, just reach out to me. And well, hopefully, or perhaps at the end we can answer some. Not sure what the time frame is. Thank you very much.
That's grand. Great demo, and delighted to see everything worked okay, because these live demos tend to go pear-shaped. Thanks again, Rex. Any questions for Rex there before we move on to the next speaker?
Nice demo. Thank you very much, sir.
You're very welcome. Thank you very much.
Okay. Gorkan, do you want to share your screen there with me again?
Yes.
Okay. And we have Carol Griffin with us as well this week. Hello, Carol. There you go. We can see your screen there now.
Yeah. Perfect. I think everything is good. Okay, perfect. Thanks for having me. Good afternoon, good evening. This is Gökhan. I'm the security guy in the room. Today I'm gonna do a quick demo and also recorded demo for about the AI securities. Let me start with a simple questions. I think so. How many of you already have an AI chatbot or RAG assistants or any AI agents running somewhere inside your organizations, let's say? Yeah, most organizations are moving incredibly fast. Everyone wants an AI production, and also that is understandable, and because the business value is real. And in many cases, we are protecting all of the nothing more than a system prompt. Everybody knows what is the prompt security or content security. But today I'm going to break one of the system's leaves 4 different ways, and then I will show you how to stop every single attacks running some of vulnerable or exploitation commands in your chatbot or in your, let's say, the OpenAI or Cloudy, Azure OpenAI, and everything else, any kind of LLMs, let's say. Yeah. What I'm gonna cover today, here's the journey. First, I'm gonna explain for the new attack surface, why Azure OpenAI and AI agent RAG changes the security model. And also, I'm gonna cover for the 9-layer guardrails for about the sandbox, architectural things, architectural walkthrough, let's say. The other one, the third one, is the 4 Leo attacks. I'm gonna starting the simple attacks, let's say, the like thinking like hacker or red teamers, and also I'm gonna show to everybody else the vulnerable or protected mode. What does it mean for everybody else? The fourth part is the sandbox. I'm the explaining for the mapping every control for it can be a Azure AI agent pattern, or it can be anything else. If you are talking about any kind of AI agents and also LLMs, SLMs, transformers, something like this. And I'm gonna cover every control attack maps. The last part is the takeaways, of course. If someone talking about the AI securities or security for AI for securities, those are the terms mixed together nowadays. But we have to understand when someone talk about the AI agent securities or AI securities or multi-AI agent securities, and also MCP securities, those are the terms is news things in our life, but we will hear more in nowadays. Yes, this is I'm gonna explain for the traditional security still matters. Network controls matters, endpoint protection matters, identity access management matters, and also applications, firewalls, web application firewalls, something. But the AI runtime attack surface is news problems nowadays in front of us. In front of us, any kind of roles. It can be database security. It can be database admin, something. This is the news era for understand the why traditional securities tools and products or values doesn't cover for the new era for coming for the AI protections or AI security coverages. We have to understand what is the prompts and what kind of prompts looks like secure or insecure. We have to understand when someone type in the chat box and when someone use some kind of LLMs, we have to understand what the model capabilities. I mean, model name is for like GPT 4.5, 4.6. It can be anything else, but we have to understand what is the model. We have to understand what is the parameters, and after that we have to focus on for how agents works. I mean, agents can be anything else. It can be mixed LLMs or SLMs. It can be only LLMs. It can be like Mistral 7B models. It can be Cuban 3.5 models. Anything else, and then we will understand the AI runtime securities. Here's the things. I'm gonna explain for about the disciplines, the AI runtime securities. I define it as the disciplines of protecting AI interactions, model access, and agent actions, and also AI-driven workflows. At the moment, they happen, but not only at the design time, not only during model evaluation, and not only after an incident appears in a log. I mean, traditional cybersecurity tools like EDRs or XDRs or SIEM solutions can easily understand some kind of log ID or event ID. Like if you are open or Windows Event Viewer or Windows Security Logs, if you are analyzed for the event ID 515, and the 515 says to you, this is the security login or successfully logged in these windows. And these are the terms that say it will gonna be in nearly on the old-fashioned things, because the SIEM solutions understand what is the Windows login or logout or any kind of actions in your Windows, in your laptops, in your operating systems, in your operating environment. But the attacker's behavior suddenly change when the AI comes in. That's reason why I'm gonna explain about of course, we are following for OWASP top 10 Gen AI security matrix and so on and so forth. I'm gonna cover for the AI runtime securities in today, because the runtime is so important. Runtime means for when you are open your OpenAI or Cloudies or some kind of chatbot or RAG or something like this. And then you are working or text to text, you are working on like the speech to text. It can be anything else. And then you are using for any kind of LLMs in runtime. We have to understand runtime securities. For example, what is the prompt injection? What is the sensitive info disclosure? What is the excessive agency? The last one is insecure output handling. Those are the 4 attacks pattern for right now, explain for the AI runtime securities. Yeah, this is the Azure OpenAI RAG agent, retrieval augment generative. I think so. Everybody asks what is the RAG meanings for, but I want to explain something about it. The first one is the chat UI. When open any kind of chatbot or chat or LLM something, we are facing the first screen is the chat UI. The second one is the Azure OpenAI service. The third one is the AI research or search parts, like our files, documents, and JPEGs, PDF files, any kind of indexed files put in our databases, and also vector embedding part. We are calling the Azure AI search. The other part is agent orchestrations. If we have at minimum 2 individual agents for working for an individual task, like first one is the document summary, second one is the text-to-text conversation, let's say. The last part is the tools. If we are talking about any kind of agent, the agent's calls, an agent reach, and an agent access to any kind of tools like emails or SharePoints or DBs or your Gmail or Outlook calendar. It can be anything else. If we are called the term the AI agent must have at minimum 2 individual tasks or capabilities. And then I'm gonna cover for the 9 individual tasks on my recorded and also mock demo. You can follow up. You can follow on my screen the 9 guardrail layers. Input guardrail. Second one is the retrieval. Third one is the retrieval access control. And the fourth one is context sensitization, instruction hierarchy, LLM provider, output TLP, output link guardrail, and the last one is the tool authorizations. If someone talking in the room for about the AI security or AI runtime security, we have to focus on 9 individual guardrails layers. And I'm gonna explain how everybody can easily follow up, or what I'm gonna drive at in my demo, how to read the live demo. The vulnerable mode means guardrails off. Before I said we have 9 individuals guardrails things. If guardrails off, systems or agents or any LLMs running natively, we can say the insecure mode, because every model has capable for, let's say, a bit capable for the guardrail capabilities. It can be the models understands this behavioral is let's say insecure, or something like this. And the protected mode I'm gonna open and I'm gonna switch on our guardrails, input filtering, output filtering, and something. And then my demo reflects to do my prompt or prompt injections attempt something. And we can easily see on my screen for the protection capabilities. Yeah, I'm gonna share another screen for my demo. Yes.
Yeah, we can see it there now.
Yeah, perfect. Thank you. Yeah, this is my current AI runtime security sandbox, and running on my local computer. And also you can fork my GitHubs, because I am the red teamer and offensive security guys. Because we cannot easily understand these patterns, easily hacked your environment, like database leakage, data leakages, something like this. And then we generate as protected sandbox, and you can integrate or enables what kind of LLMs do you have. Like it can be OpenAI, Cloud, Gemini, or custom LLMs. But for now, I'm gonna run for mock demo, because those are the attack patterns can easily understand Azure OpenAI agents. What something goes wrong in our AI agent, and suddenly dropped my session, and after that I'm gonna isn't followed for my task. The demo scenario is, the first one is, you can easily see on my screen. I'm gonna a bit zoom. The first one is indirect prompt injections. The indirect prompt injection hidden inside retrieve document hijacking. It will try to reach out the database and understand and try to like SQL injections, something like this, the attack pattern. And when I put some kind of message in my chat, can you summarize the payment terms in the vendor contract, and send it? But the mode is vulnerable, guardrails are off, and then let's see what will happen. And the systems and output tokens, output message says to us, this is our reply back. And then when I turn on and guardrails are on, I will resend again this message, and then can you summarize the payment terms again? And the reflects for this is the vendor contract reflections. We under protect. This is the attack. And then how can I understand this is our vendor terms documents, and those are the details. For now, I'm gonna explain for what kind of architecture behind the sandbox. When you send this user message that I sent right now, and the input guardrail, reg retrieval, the retrieval access control, context sensizations, instruction hierarchy, LLM provider, output DLP, output link guardrail, tool authorizations, and response. I put a couple of the offline data, the offline agents, and also company overview or confidential salaries, documentation, and HR policies, some things. This is my local knowledge base. And also tech stack, I use the FAST API front-end, the vanilla and HTML and CSS. And LLM providers, you can use any kind of LLMs. And these are the scenarios. This is the system architecture. And the second attack I'm gonna try, and I'm gonna demonstrate. First, I'm gonna turn off my guardrails functions. I'm gonna run the second attack. This is the data leakage. And when I put in the push to message, and can you share the salary bands for each position at the companies? This is the mid-level software engineer salaries, and this is the cloud engineers. Those are the message comes from our HR salaries or confidential salaries documents. But this mode is vulnerable. When I open or switch on my protected mode, guardrails are on, and then I will send again the data leakage, the same message. And then based on document, no relevant document found. This is the guardrails are on. Understand what kind of informations try to search and try to reach out in your databases. This is the very confidential. Everybody knows the salaries is our hidden. And then the demo is correct verbs. The third one is, as you can see, the 9 individual tasks, but I'm gonna quickly cover the third one, and after that I will finalize it. The excessive agency tool abuse. This is highly popular attack at nowadays. 3 weeks ago, Cloudy has been leakage from the North America part, the retails companies. The companies is also hidden, by the way. And the explanation is the sum of wipe codings suddenly hacked our databases. All hidden or privacy informations in our databases has been leakaged, all of the data. The breach amount is approximately, they will calculate and share the media, and approximately $1 million. This is the tool abuse exfiltrations attack. And I'm gonna quickly and send it the attack, but first I'm gonna guardrails switch on off and send it can you summarize the support ticket something? They are trying to reach out in your current environment support ticket archive and see something. And then you can see the email, blah, blah. And I'm gonna open again and resend the message. I'm gonna got the reflection for the attack naturalize. These are the things call AI runtime security. It's gonna be put on your Azure Open AI. It's gonna be chatbot or ChatGPT, it doesn't matter. Every LLMs can easily be hacked from anybody else, any hacking group. Like it can be APT1, it can be 41 APT attackers group, something. We have to aware of the OWASP top 10 Gen AI security architect for any kind of LLMs. How can be easily hardened in our Azure OpenAI systems, something. The last part is, I'm jumping on the next top. And as you can see, Azure OpenAI and Explore Foundry portal. I believe so. Everybody very familiar for this part. And the Azure OpenAI, as you can see the menus, the guardrails and controls. basically support and can cover our Azure AI agents, OpenAI agents, something, and guardrails and controls, safety and security guardrails, and agent controls, data controls, and something. Some of part easily managed by the human in the loop. It can be, we can call the authorizations. The other part is data control. It can be covered by purview. The other one is the safety and security guardrails. We can understand the content, how AI applications works. If we know about how AI applications normally or abnormal works, we can understand that this is the insecure call, or this is the prompt injection attack attempt by anyone else. We can easily deploy. Those are the technical details on your Azure OpenAI and Azure OpenAI system, something like this. The last part is you can deploy for your agent. You can see and you can choose your what the models for works for you, like the chat completions, text to text, any kind of NLPs, something. That's all from my part, by the way. I'm gonna send all the details after this session. If somebody else wants and wonder much more details about the behind the scenes and any kind of technical details, how I can attack and how I can harden my AI agent systems, also Azure OpenAI systems and Azure OpenAI AI multi-agent systems or Purview something. And let's connect. Thank you.
Very good. Great presentation. Great demo. And we had somebody from the audience there, just throw it up on the screen there, was very interested in. He says, hi, I'm doing the AB 900 soon, and this looks interesting. Thank you. Any questions for anybody, from anyone? No, very good. So we have our third speaker up, and Taja, Dr. Taja Gross. And I'm just going to put your screen up there now. There we go. We can see it. AI agents have no help path.
Frank, thank you so much for having me, and to the amazing Azure and AI Show team. Thank you so much for having me. I'm excited to be here because I believe we're really at a pivotal moment here in how organizations begin to think about artificial intelligence. So I'm just so glad that I was able to hear my colleagues before me. I want to begin by talking about the title of today's presentation. Your AI architecture is already making decisions. And at first, that sounds surprising because most people think AI starts with making these decisions when a model generates an answer. But if you think about it, it's actually the last decision in the process. And the first decision essentially happens much earlier when leaders determine what success looks like. And they actually begin to kind of delve into data that we're using, and when we start thinking about the business rules that take priority and what level of confidence is accepted in our models and systems, when automation becomes a part of our architecture, this is essentially when humans need to step in and be a part of that process. And by the time an AI model produces an answer, we know that it is already too late and that leadership has already made dozens of decisions that shape that particular outcome. And that's why I believe our organizations aren't just deploying AI, they're deploying decision systems and architecture. And that's why this work is so important. And so I'm Dr. Taja Gross, founder and CEO of Ethelect. My work focuses on helping organizations build AI systems for people so that they can explain, govern, and defend the decisions that they make. One of the frameworks that I've developed that we're going to talk a little bit about is human intervention architecture, which focuses on helping us to intentionally design where human judgment should remain a part of our infrastructure and our intelligence system. So AI really shouldn't just simply know how to answer questions. It should also know when it shouldn't decide alone. And so I'm really excited about that. So I think many organizations have been asking the wrong question. We typically ask, when can AI automate? And that's a really important question for us. But I think what's more important as we begin to make these leadership decisions around our architecture and what we have at the forefront of our work, what decisions are we designing, and what decisions are we allowing our architecture to design for us? So AI doesn't invent an organization's judgment, it actually scales it. And so every organization has already decided what it values, it's decided how it wants to show up, whether it's through a customer service app, healthcare app, banking agent, public safety risk rules and escalations that we have. AI simply operationalizes those decisions faster and at a greater speed and scale. So when people essentially ask whether AI is biased, I often respond with another question: what assumptions have already existed before AI even entered the process? And so this is why I'm really excited to have this conversation today, because AI rarely invents the organizational thinking. It just mirrors back to us and reflects back to us um, what we've been thinking as a part of our process. So that's why I believe architecture deserves so much more attention than it has been given recently. And one of the biggest conversations happening right now is around AI agents, right? So everyone is excited about autonomous systems, and they should be. They actually are incredibly powerful. If you think about all of the AI agents that you see here, working independently and doing some of the heavy lifting. But I think we're also overlooking one very important question, and that is, what happens when the agent reaches the edge of its judgment? And so, what happens when confidence is low? What happens when information conflicts? What happens when the decisions carry significant ethical, legal, and financial consequences? Who does the agent ask? Where does it escalate? Where do we pause in our infrastructure? Those aren't engineering questions alone. That's why I often say AI agents don't fail because they're unintelligent. They fail because they haven't intentionally designed what happens when they shouldn't decide alone. And so I'm very excited to talk about that. If we move to the next slide, this kind of brings me to the framework. So organizations spend an enormous amount of time discussing governance. We're creating policies. We're a part of ethics committees. We have security rules, escalations. We talk a lot about compliance and where that fits into the governance of what we decide is important around what we already know. And also, as we begin to audit our rules and escalation paths, we begin to think about all of these things being important, but governance doesn't become real until it lives inside of our architecture. And so human intervention architecture asks very practical questions. Who does AI pause for? Who reveals the exception? So when we think about who is owning this, who owns the final decision when we use our AI agents, and who has the authority to override the automation? So when does uncertainty require human judgment instead of another prediction? So these design decisions are a part of our architecture, and we need to determine whether AI earns our trust. Let me say that again. Who decides and determines whether AI actually earns our trust? Not because AI isn't capable. AI has proven to us it is highly capable, but because accountability doesn't emerge automatically, we know it has to be intentionally engineered and designed into the infrastructure, into the workflow. So leaders often ask me, like, where does this actually begin? And my answer sometimes surprises many, but it doesn't begin by auditing the model. It begins by mapping out our decisions. And how do we do this? We begin to ask what decisions are being made. Again, who owns them? Which assumptions are being embedded here into the system? And what confidence level triggers the escalation points that we tend to want to make sure that we have in our systems, and who can actually intervene. And that's really important. And how do we explain the outcome? Once organizations understand their decisions, then I think governance becomes much more practical for us to embed into our system, because now you're improving the system before the problem actually becomes public. And so I'd like to ask everyone listening on today to our conversation, I'd like to ask you one question. What decision did your AI inherit before it ever made one on its own? And I think that's important. One of the most important questions leaders can ask themselves today.
This is Carol. I think one of the most important questions before we even start to build an agent or even start to do anything with AI is the infrastructure and the alignment with the goals in mind, with the functionality, with the infrastructure, and the guardrails from legal, the business. All of that needs to be into consideration before you even start building one feature for AI. And that needs to be a start of a solution prior to taking all of that into advantage and looking at the risk early and just having some roadmap and what the outcome that you're looking for, instead of just diving in first and then thinking about those things kind of in the middle or the back end. So those are just some of my thoughts.
And Carol, you raised some incredible insights, because every automated decision eventually becomes a human experience.
Mhm.
And what we're saying is that organizations have to earn trust. And the way that we earn trust is by intentionally designing where AI should pause, escalate, and return judgment back to people.
Correct.
And so thank you so much, Carol, because that was absolutely incredible. So I just want to make sure that I close with this, because I think this is really important. Technology doesn't determine the future of AI, leadership does. And so the organizations that earn trust won't simply build more intelligent systems. They'll build better decision systems, systems that know when to automate, systems that know when to escalate, systems that know when human judgment matters. Because this is my philosophy, and this is what I truly believe. Because we don't design systems around what AI can do, I believe that we design systems around what leaders need to decide. And so every automated decision eventually becomes a human experience. And so I just want to thank you all for allowing me to have this conversation with you on today.
Bravo.
Very good. Great presentation and great insights. We have one question from our audience. 1 second there now. Just put everyone back up on the screen, and I'll just share this question that came in. So how often do you think this should be reviewed, and should leaders have a role in that review? I think that's for you, Dr. Taja.
Yes. Karam, thank you so much for your question. So, absolutely, leaders should be a part of this review. And it's really important that this review happens regularly and that there's a cadence for how, whether it's quarterly, but there should be a true cadence that's happening as a part of the review process. That review process should include a number of things, but I suggest that we keep an AI governance journal. It's one of the things that I believe keeps us in front of making sure that human intervention architecture is in place. So I recommend keeping an AI governance and decision journal, and it allows you to audit those decisions, have those conversations about when is the right time to escalate, who should these pathways and workflows escalate to, who are the persons who are the gatekeepers, I want to say, of that process, and how do we continue to make sure, because again, AI agents have to earn our trust. I want us to really think about that. They have to earn our trust, and so we are the leaders that are responsible for the decisions and what AI potentially decides for us. You can continue getting resources if you go to my LinkedIn page. You can find me at Tasha M. Gross, PhD, and you'll see that I have a decision mapping document there that you can use with your team that will also continue to help you on your journey of decision mapping. And you can learn more about the AI governance and decision journal as well.
Very good. We have another question there from the audience as well, and I say it's probably pointed towards Goran. 1 second now. So this one here on the screen. Do you suggest that companies should set up sandbox?
Yes, definitely. I will suggest for if you want to do like the some exercise what the agents runtime securities. If you want to learn and if you want to more capable the AI agent securities or AI securities, you should definitely deploy. It will take only 10 up to 15 minutes, and then you will learn more a lot. The best part is the 100% offline. Doesn't happen in your environment. That's it.
Very good. And this is another, we've got some good questions in and from the audience tonight. So this is, I'm a new to this session. I'm currently learning Gen AI. I hope this session will help me to learn something new. So yeah, that's only just some of the comments coming in. Yeah. So yeah, we had a good session and good comments coming in from the public on LinkedIn, and just see, can I find and link to your
Frank, may I make one comment to the
Yeah.
last person, if I may?
Sure, work away.
I know you're new to governance, and thank you so much for being a part of our conversation. I think one of the other insights that's really important around what's happening here is that AI doesn't just fail suddenly. I just want to make sure um, that we put that out there. Most AI failures don't just begin with some type of catastrophic event the way that we typically hear it playing out in the media. It usually begins with a series of decisions that nobody has questioned because each one seemed so small that it didn't matter, and it eventually just escalated into what then becomes the public outcome.
Okay, I just wanted to share something here. 1 second now. So there you are. If people want to contact you on LinkedIn, can you see that on the screen there, guys? So I can put that up. Um, 2 seconds now. And hide that one. So that's your LinkedIn there, Tasha. Yeah, coming up on the screen there. So yeah, so we're gone over the hour. Thanks everyone for joining us this week's Azure and AI show. We're back next week, and we have 3 more new speakers. They are going to be talking about AI governance and frameworks, hardware software interactions to support agentic workflows, and we have another speaker learning from AI distributed systems, and we have another speaker configuring administrative units in M365 Admin Center. So a lot of AI stuff coming up next week. So I'll be posting them on Tuesday, and that's it from this week. So thanks everyone.
Thank you so much for having me. Thank you, audience. Have
Thank
a
you very
great
much.
day.
Thank you so much.